format string 3. This program doesn't contain a win function. How can you win? We have links to download everything. We have a port to connect on, and a hint, is there any way to change what a function points to? All right, so we'll first look at the code. We have this normal string bin sh. That's going to be important because we would love to run bin sh. Setup calls setvbuf 3 times. And here's hello. It calls putS. That's important because we're going to be using the global offset table, and the global offset table gets filled in the first time a function is called. So putS being filled in before we get to the one we're going to exploit matters. And it prints out the address of setvbuf. This is also important because libc is loaded at a random address in memory. And so we need to know one fixed address in order to figure out where system is, because we want to call system with bin sh in order to win and get the flag. Our format string vulnerability is right here. We have that call to printf with no format string. We get to specify whatever we want as the buffer. So we're going to pick a buffer that changes the address of putS to be the address of system. All right, so let's look at some things in Ghidra. So here is libc. I've loaded libc. You'll note that the address of setvbuf is 17A3F0. When we actually print that out, we're going to get a large random number that will end with the 3F0, but the prefix will be random. And so we'll want to change the last 3 bytes from the 17A3F0 to that of system. Actually, it won't be this, because we'll actually be putS, whatever putS is. But we'll know the address of setvbuf. So we'll want to change those last 3 bytes to be something related to 14F760. All right, so we get the address here. So you'll note that 3F0 matches. This byte 3E is different. We have a whole random prefix. And then this nibble is also different. So that's going to be a little bit tricky in getting this. We'll want to write for system all of these bytes will be the same. Actually, they'll already be there because putS has been called. So we don't have to worry about these bytes or the zeros before them. We will only have to worry about these bytes. And so we'll want to change them to not be 3E43F0, but the related bytes for system. Okay, I've written a little program here. We're going to use HHN to actually write bytes. That's a format string specifier that writes to memory the number of bytes written so far in the printf. But we need to find our addresses in the string, so I'm going to send this long 40-character string with a number of addresses. So these addresses come from the code for the GOT entry. So the procedure linkage table for the GOT entry for putS is at 404018. So 4040, this is a little endian order, so 404018, 404019, 4041A. It's hexadecimal, so that's not 404020, it's 4041A. Those are the 3 bytes that we need to change. This address here is the resolver at 405008. It will already have been resolved by that first call to putS, so all of these 0 bytes will be the correct prefix. We'll just need to change these 3 bytes to be what we want. By running this a number of times and changing these values, I discovered that 43, 44, and 45 spots up the stack are where this portion of the string is. So you'll see 43, 44, and 45 spots up the stack give me those 3 addresses. So I get that address. I'm going to parse it into its second byte by removing the new line, dividing by 256 to get rid of the last byte, and modding by 256 to get rid of all the bytes before that. The second difference, what I call that, is I subtract out A3. So that A3, if we look here at setvbuf, there's that second byte. So I'm figuring out the difference between the random, because that first nibble of that byte will be randomized. So I'm figuring out the difference between that and the A3. So that's my second difference. The third byte, counting from the right side, I get by removing the low 2 bytes by dividing by 256 squared, and then modding by 256. Now, unfortunately, printf has a very short buffer that it allows you to do. I can't just write the number of characters for the last 3 bytes or even just the last 2 bytes. So I have to write it 1 byte at a time. And I'm going to write the third byte, so counting from the left, the third byte, then the first byte, and then the second byte. The reason I do that is because 60 is less than, hex 60 is less than F7. So writing to this first gives me a smaller number of total bytes than write. So that third byte should be whatever setvbuf's third byte is minus 3. And the reason for the minus 3 is you'll note that there was 17, hex 17 for setvbuf, and then for system it was 14, so I need to subtract 3 from whatever the third byte was. And so that's what I'm going to put as the third byte. The second byte is the least significant. So it's the first byte counting from the right, but it's the second byte I'm writing. I just want to change that to be hex 60. So I take 60 plus 200, hex 60 plus 256, subtract how many I've written so far, mod that by 256. This just prevents me from having to deal with negative numbers and gets removed by the mod 256. Then for that third byte, I want it to be F7, right? So it's the third byte written, but it's actually the second byte counting from the right. I want this F7 plus whatever difference we saw from second diff. So my third fix is, I know I'd written 60 hex bytes so far. I want F7 plus second diff. I take that, and that's my third amount. Printf, as I said, probably has a 512 byte buffer, so I print my amounts of bytes that I've written. And if that thing ends up being more than 512, it probably will fail. And then I'm going to send this thing. So I send % a number u, so that will print a parameter on the stack in this number of digits, 43 HHN, so that's going to be this 1A address. Then I do my second. Then I do 45 because I'm writing to that least significant byte. Then I do my third number I computed with 44, which is going to be that middle byte. Then I do R interactive so I can interact with these things. So I will have written the bottom 3 bytes in the GOT for putS, replaced it with the bottom 3 bytes for system, and I will be calling system instead. All right, so this time I was fortunate. The number of bytes so far wasn't bigger than 256, so I'm running a shell on their server. I can do ls, I can do cat flag, and I get this pico_ctf got. So by using those format string specifiers, I rewrote 3 bytes in the global offset table, procedure linkage table, to change the address of putS to be the address of system, and that is going to give me my flag.